Hi guys, welcome back. Welcome to part two of complex numbers. And now we're going to start our operations with complex numbers. And we had a little bit of operations with complex numbers because we understand that I squared is -1 and square root of -1 times the square root of, something else. We can break that apart. But now, we're going to look at examples of those operations: addition, subtraction, multiplication, and then division. Division is probably the most difficult part because of this guy right here. Understanding the complex conjugate is probably the most difficult part of this whole thing. Addition and subtraction are super simple. So let's just take a simple idea of two binomials. Let's do 6 plus I. This is your example on your study guide. And we're going to add to it 4 minus 5I. And we're going to do just what it says. I mean, this is so simple. They broke it up into 6 plus 4, 6 plus 4, and then they broke it up into I minus 5I, and they actually broke it up into, pieces. I don't like that part. I minus 5I. I want to see it just like this, right? And we add those two together. That's okay. It's kind of annoying. Let's do this. I want you to think of I as sort of a variable. You can't add these two together, right? Because we can't add the square root of 1 to this, right? But we can add 6 and 4. So we're going to add 6 and 4 together, and we're going to get 10. And then I plus negative 5I would just be negative 4I. Imagine this was an x for our purposes here in terms of complex numbers, right? Do it the easy way. Don't do it the way they're showing you in the book, because it's a little bit more complicated than it really needs to be. So let's work on subtraction. The subtraction piece says, I'm going to give you 8 plus 3I, and then I'm going to subtract from it 6 minus 2I. Now, subtraction and a negative, don't forget. So I usually just play the touch it game and say 8 minus 6. Well, 8 minus 6 is 2. And then I say 3I minus a negative 2I. Minus a negative is like plus a positive. So I would be adding 2I to it, and I come up with 5I. All right, if you want me to write out the middle step there, it was 3I minus negative 2I. Because you can't forget that minus sign. A lot of times kids forget this minus sign and this subtraction symbol in here, or this subtraction symbol here, and it gets all messed up. But minus a negative is like plus a positive, and that's what gave us that 5I. Okay, so addition, subtraction, very super simple. Good part about multiplication is it's basically FOIL. That's all it is FOIL. And so when you're given something as simple as, pardon me, let's just use the same color. 2 minus 5I times, and they put a multiplication symbol in the middle, but you don't have to. I mean, come on, man. You guys are too smart for this. We don't need the baby stuff in the middle. Let's just FOIL. It's telling us to FOIL. Let's just FOIL, for goodness sake. 2i. Sorry I'm taking so long with this, but I get frustrated when silly stuff happens. So 2 firsts, 2 times -4 is -8. Outers, right? Plus 2 times 2i. Now we can do that, right? Because we're upping I by a factor of 2. So we have 4i. All right. And then we'll do the inners. -5i times -4. Okay, well, negative times a negative is a positive. So we're going to say it's plus 20i. So we're almost done. -5i times positive 2i is -10. Here's the kicker. I times I is I squared. And don't forget, remember, we said that I squared is -1. So I can evaluate this and make it 10 times -1, or minus -10. So this is plus 10. So the whole thing looks like this. -8 plus 4i. Plus 4i plus 20i is 24i plus 10. Well, I can put my -8 and my positive 10 together. So I have 2 plus 24i. All right, and it's as easy as that. All right, so there's some simplification that you do at the end that you wouldn't, normally do. You would just combine those middle terms, but there is something you can evaluate over here, and we're done. So let's move on here. This is the most interesting piece of working with complex numbers, and it is the division. It's having complex numbers in your denominator, and not just a complex number, because having a complex number in your denominator is no big deal, unless we'll get there. It's no big deal. Here we go. Are you scared? Don't be scared. It's very, very simple. I'm going to give you 2 different types of examples. One, where we're going to have to use the complex conjugate, and the other, where we actually just split it up and divide both pieces of the puzzle. And here I go. Get rid of that, and now I can start writing. We have what is written as 3 minus I divided by, what is it? 2 plus 5i. Okay? This says to simplify this and not have our I in the denominator, all we have to do is multiply by the conjugate. Now, the conjugate is the opposite of this, okay? And what I mean by the opposite is, instead of 2 plus I, it's 2 minus 5i. Okay? And that's it. But if I do it on the top, on the bottom, I have to do it on the top, because this 2 minus 5i over 2 minus 5i is just 1. So I haven't changed the true value of this fraction at all. So What do I have to do? Oh my God, it's FOIL, 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 FOIL. But I'm going to tell you, here we go. The product of complex conjugates is always a real number. And remember what I told you before, that when we multiplied, when we FOILed, and they were opposites like this, the middle term goes away. I'm going to show you again because I have to, but I don't want you to get upset. I'm going to do the top first. I'm going to do 3 minus I times 2 minus 5I. Now this we're going to have some complex number on top. And so I'm just going to do this right over here. 3 times 2, of course, is 6. 3 times minus 5I is minus 15I. Minus I times 2 is minus 2I. And then minus I times minus 5I is 5 plus 5I squared, which is minus 5. Right? Remember, I squared is negative 1 times 5 is minus 5. Negative 15 and negative 2 are negative 17I. And then there's the 6 up front. So 6 minus 5 is 1. And I'm going to need this down here. I'm going to put it in a new color because it's going to be part of our final answer. 1 and then minus 17I. Did I do that? Oh, I wrote it all wrong. Whatever. This almost matches your example. I did it. I wrote 5I instead of 3I. Here we go. 2 plus 5I times 2 minus 5I. 2 times 2 is 4. 2 times minus 5I is minus 10I. 5I times 2 is plus 10I. See, they're going to cancel out. They're opposites of each other. And 5 times 5 is 25, but this one's negative, so it's negative 25. And then I times I is I squared. 25 times negative 1 is negative 25. And negative minus a negative is plus a positive. So we have these two things cancel out. 4 plus 25. All right. And then there it is. 4 plus 25 is 29. Dork. There we go. Sorry, I'm calling myself names. Getting tired. There's 29. And that's it. That's how you do it. We got rid of the imaginary number in the denominator. Everything's hunky-dory. I know this is bothering somebody out there. It's actually bothering me. So I'm going to get rid of that and then rewrite. But it's all done. If you want to go away, that's totally fine. I'm going to just write 29. There, so much better. That's it. You'll be able to do your homework from here.